Tomorrow will be better. State two necessary conditions for total internal reflection. Follow me, dear friends. Solution. In order for us to understand clearly what happens here is, let's consider this diagram here, this illustration. We all know that when a ray is leaving a denser medium, for example, glass, into a less dense medium, that ray has the tendency of being refracted away from the normal. So let's consider a first incident ray. Let's call it I1 in blue. You notice that when I1 crosses its boundary, it is refracted away from the normal. So now look at the other one, I2. Let's call this ray in red, I2. You will notice that since I2 is greater than I1, its refracted ray also is greater than the refracted ray of I1, and it moves farther away from the normal. Now, these two tendencies already reveal to us that the further or the more you increase the incident angle or the angle of incidence, the greater the refracted angle. I repeat, the greater the angle of incidence, the greater the refracted angle. If we follow this same tendency, we will realize that there will be another angle of incidence, this time around I3, such that the refracted ray now is going to be 90. 90 degrees means that that refracted ray, which is in black here, will fall exactly on the boundary between the two media. I repeat, if we continue increasing the angle of incidence, then we will stumble on a certain angle of incidence, let's call it I3, such that its angle of refraction will be 90, which means it falls exactly on the boundary between the two media. And in physics, dear friends, this angle of incidence that produces a refracted angle of 90 is what we call here the critical angle. This is what we call the critical angle. If we follow this same tendency right from the start, we will notice that if we increase this critical angle even just by 0.1 degrees, we will notice that this refracted ray will now follow this kind of pattern, which means the refracted ray finds itself in the medium of origin, and this is what we call total internal reflection. Therefore, to wrap it all, the two sufficient conditions for us to experience total internal reflection are, number one, we must be dealing from a denser medium to a less dense medium. For example, glass to air, water to air. Two, the angle for total internal reflection must be greater than the critical angle.